choose some. Okay, so let's get started. The first question on the test is very easy. It's from lesson 4.1. So what they're gonna tell you is, you're gonna find the inverse of, this is the first question, find the inverse of f of x is equal to 2 over 5x plus 24. This is the question on the test, the first question. I will give you a function, something like f of x is equal to 2 over 5x plus 24, and I'm gonna ask you to find its inverse. Okay, let's try to solve this problem together. Does anybody remember the steps? Change the f of x first. What does f of x change with? Y. So first step is we drop the f of x and we just rewrite y equals, and then we just keep the rest the same, 2 over 5x plus 24. Because to find the inverse, we need a y and we need the x, right? Okay, this is always step number 1. What's step number 2? Then always we exchange the x and y. Where we see y, what am I gonna write? X, 2 over 5 gets copied. Instead of x, what am I gonna write? Y plus 24. This is the most critical step here, exchanging the x and y to find the inverse of the function. Okay, are we done? Now the last step will be isolating the y, because once we isolate the y now, that's gonna be the answer we're looking for. How can I isolate the y here? You can do that to get rid of the fraction. That's a very smart step. So you can just multiply everybody by 5. If you just multiply everybody by 5, what happens is I get a 5x now, and then the whole thing we were multiplying everything by 5, so this top 5 cancels the bottom 5, and we have no more fraction in our problem. That's just a 2y. And then when I multiply 24 by 5, that makes 120. So we didn't solve for y yet, but this is a very important step. We got rid of the fraction and we got a lot easier problem. But my task continues. I still need to solve this for y. How can I solve this for y now? Subtract 120 from both sides. Very good. So I get 5x minus 120 is equal to what number? 2y. Is y isolated? What's the only thing now bothers the y? 2. So everything will be divided by 2. Everything will be divided by 2. So here the top 2 and the bottom 2 cancels out. So this is the answer we got. But instead of calling the answer as y, what am I going to call it as? F to the power of negative 1 of x, right? This means inverse. So now we just found the inverse. Instead of y, we just call it f to the negative 1 of x. And then the answer we got is 5 over 2x minus 120 divided by 2 is just 60. This is the answer on the test that you will choose if this question shows up as number 1. This is how you find the inverse of a function. This is lesson 4.1. We learned this under lesson 4.1, finding the inverse of a function. Any questions about number 1? We have one more about inverse functions, which is very similar, so we're going to repeat this process again. All right, number 2 is a little harder than this, so I'm going to move here for number 2. I'm going to write the question first. It says, solve the exponential equation, which is 27 to the power of 3s minus 6 is equal to 9 to the power of 4t plus 8, 4s. Okay, let's read the question again. Number 2 is a lot of letters. It says, solve the exponential equation And the equation itself is 27 to the power of 3s minus 6 is equal to 9 to the power of 40 plus 8 for s. So we're going to solve this equation for s. We're going to isolate the s. Yes.
S of what? S.
Let me read it again. This is 3s minus 6, and this is 40 plus 8. 3s minus 6. Okay. Anybody remembers what lesson is this? Lesson 4.5. Exponential equations and log equations. So you can go to your Alex assignment to find similar questions. Okay. So let's get started solving this problem. What do you think I'm going to do with 27 and 9? Good job. 27 and 9, they are both powers of what number? 3. So the whole reason they gave us a question like this to check if you know 27 is 3 to the what power? 3. So we're going to replace the 27 as 3 to the third power because 27 is 3 to the third power. But this 3 to the third power will be still raised to the what exponent?
3.
Very good job. Equals. Instead of 9, what am I supposed to write? 3 squared is still a 9. And 9 gets a power of 40 plus 8. So we're trying to get them in common basis so we can set the powers to equal to each other. That's the whole point here. Okay, so the first step was changing the 27 as 3 cubed and changing the 9 as 3 squared, and we kept everything else the same. Yes, because we have an exponents rule. If 3 has 2 powers, the rule is we have to multiply these 2 powers. So 3 times 3s makes 9s, and 3 times negative 6 makes negative 18. Very good job. We're going to do the same distribution on the right side. So the base number is still 3. 2 times 40 is 80. And then 2 times 8 is 16. So that's how we set up the equation now. The equation is a lot better than what we had originally. They both have a 3 as a base number. They're equal to each other. All we have to do is now set the powers equal to each other. What is the power on the first side? 9s minus 18. And what is the power on the other side? And what are we solving for? S. So we're just going to leave the S alone. So we just need to add 18 to both sides. So 9s is equal to 80 plus, when I add these two numbers, I get a 34. All I have to do is, as a last step, I need to divide both sides by 9 to leave the S alone. So the expected answer for the test is 80 plus 34 divided by 9. This is what you will pick from the answer choices as an answer for number 2. And this is a problem from lesson 4.5. Yes, sir. Yes, but because it's a multiple choice, they put the answers like this. Therefore, I wanted to show you the answer, how the test looks like. Okay, this is how the test looks like. All right. Anybody has any question from our second problem on the test? All right. Now, question 3. So we just finished 2 problems. We're on now question 3. So we're going to write down the problem first. Solve the nonlinear system. So it's giving me a now nonlinear system. And then the system they gave me is x squared plus y squared. I'm just going to find the number a little bit after I thought about it. Just make this a 4. I believe I calculated the number correctly. I hope it's gonna work. So I just wanted to make it super close to what you're gonna see on the test. Okay, so here's what the test says. Solve the nonlinear system. First equation is x squared plus y squared is equal to 86. Second equation is y equals square root of x minus 4. Question continuous. It says let S be the sum of the y values. S be the sum of the y values of the solution. Y values of the solutions. Find S. If there's only one solution to the system, then the S will be just the y value of that one solution. So that's what the question is. We're going to solve the system, and then once we solve the system, we're going to add the y values of each solution, okay? X squared plus y squared is equal to 86, and y is equal to square root of x minus 4. Does anybody remember what lesson is this? Lesson 5.4. Good job. That's where we learned them about lesson 5.4. Okay, now who can help me how to solve this system? What am I going to do first? Very good job. We just did this last week. Since y is given as square root of x minus 4, but we need y squared on the first equation, so we're going to square both sides. When I square the both sides here, y becomes y squared, and when we square the right side, what do we get? Good job. The radical disappears, we just get x minus 4, right? Now the other equation is given as this. The other equation is x squared plus y squared equals 86 is given, right? Are we keeping the x squared? Yes. But instead of y squared, what am I going to write? Good job, because I'm going to just have one type of variable by this way, right? 86 is going to move to the other side as negative 86, and the equation will be set to a what number? 0. Very good job. Let's organize this. I get x squared plus 1x, negative 4 and negative 86. When I combine them, what do I get? Negative 90 is equal to 0. So this is what I actually need to solve. What kind of equation did I get it now? It's a quadratic equation. What should be the first technique I should use to solve a quadratic equation? Factoring. So we need to factor this. The number is a negative 90, so I need two numbers. When I multiply them, they're negative 90, and when I add them up, their sum is just 1. What are those two numbers? Positive 10 and negative 9, because when we multiply them, it's negative 90. When we add them up, it's a positive 1, right? Therefore, first factor is x plus 10. The other factor is what? X minus 9. Did we solve it? Not yet. Now we're going to take the each factor, set it to 0. So this generates x equals to be what number? Negative 10. The second one is x minus 9 is 0. So this one, x equals what? 9. Are we done with the problem? We have to calculate the what? Y values, because remember the original problem, it says, let S be the sum of the Y values of the solution. So they want us to still keep working, and we need to find the corresponding Y value for each X. How can I find the corresponding Y value for each X? In the problem, they told me that Y is always take the square root of X minus 4, right? Okay, so which one do I don't even need to do any work? This one, no solution, because we can't take the square root of a negative number, right? So this, we just have to eliminate it. But let's calculate the Y here. It's square root of X minus 4. This is the formula. So the Y is equal to 9 minus 4. What's 9 minus 4 is equal to? Square root of 5. So since there is only one Y value here, S will be the only Y2 value. So if I just call this as Y1, and then this one is Y2. So the only expected answer is square root of 5 for this question. Since there was one solution only, when we add the Y values of the solution, This is what we get for number 3. This is a problem from 5.4. Okay, that's number 3 for the test. This also a question style that you're gonna see on the final exam. Whatever we're doing here, actually we're both reviewing for final exam and the test because everything also shows up on the final exam. Question 4 from the text. It's an easier one. What is an equivalent expression for log base b parentheses m equals to negative k? So what is an equivalent expression for log base b of m equals to negative k? So this is actually a question asking you, can you change this log equation to an exponential equation, right? And we have done tons of these. Where do I start? Yes, the base is b. It still becomes the b base for my exponential equation. B will be raised to the what power? Negative k. And we're going to set this equal to what? This is exactly how we turn a log equation to an exponential equation. So b to the power of negative k is equal to m. This is how a log equation can be converted to an exponential equation. But here's the thing. Unfortunately, this answer is not available on the test. We have to keep changing this. This is a negative exponent, and they don't like negative exponents. So in order to change this to a positive exponent, what am I going to do? We're going to raise both sides to what power? Negative 1. If I raise both sides to negative 1 power, b to the power of negative k and negative 1. Negative times negative is positive. So k times 1 is just k. And then this is m to the power of negative 1. They will still not like this because in math, we are required to change m to the power of negative 1 as, good job, 1 over m. And this answer will be available on the test for you. This is the expected answer they want on the test for this question. B to the power of k is equal to 1 over m. Yes. How I got the fraction, this m to the power of negative 1 to be 1 over m? Okay, this is, I believe, lesson 4.3. This is, I believe, 4.3. Okay. Now, let's move to the 5th question on the test. 5th question on the test is, solve ln x minus 2 equals to ln 14x minus 32 minus ln x plus 7. So this is still 4.5, solving logarithmic equations. On the test, we're going to have ln of x minus 2 is equal to ln of 14x minus 32 minus ln of x plus 7. We're going to solve this equation for x. Okay. So let's start with this one. First, we're just going to copy the first side, right? ln x minus 2 equals. Can you guys tell me what rule I can apply? If I have a subtraction between two ln functions, what can we do about them? Yes, we learned 3 important rules about logarithms. One was called product rule, quotient rule, and power rule. Which one applies here? Quotient rule. If these two logarithmic functions are getting subtracted, that means we can write them together, right? I don't need to have two things. I can have just one ln. So who's going to be at the top?
14 X.
minus 32. Because of the subtraction, we have to divide the numbers, and what's the other one? X plus 7. We just apply the quotient rule. Okay. Now, if they are equal to each other, this one got ln, this one got ln. So all we have to do is set x minus 2 to equal to 14x minus 32 over x plus 7. Because this number here has to be the same number as this one if they're equal to each other. X minus 2 must be the same number as 14x minus 32 over x plus 7. Okay. Where is this going to take me? Now we're going to do what? Cross multiplication. Yes, cross multiplication. So we're going to multiply x minus 2 by x plus 7. And we're going to set that equal to what? 14x minus 32. This is called cross multiplication. X minus 2 will be multiplied by x plus 7. And there's an invisible 1 here, even if we don't see it. And 1 will be multiplied by 14x minus 32. Now, x times x is x squared. X times 7 is 7x. Negative 2 times x is, and negative 2 times positive 7 is, good job. As you can guess, this is going to take us to a quadratic equation. So let's move everything to first side. 14x will be moved to the first side as negative 14x. And negative 32 will be moved to the other side as positive 32. So this whole thing is said to be what number? 0. Okay. Let's organize now. This is the x squared, 7x and 2x. When we combine them, that's a positive 5x. And then I have negative 14x here, that's a negative 9x. Negative 14 and positive 32, when I combine them, I believe that just makes an 18 is equal to a 0. Okay. This is a quadratic equation. Remember my very first sentence to you. College algebra is all about solving quadratic equations. How can I solve this quadratic equation? How many factors we need?
Plus 3x and minus 3x is 9.
Okay, this is positive 7x, this is negative 2x, so 7 minus 2 is 5. And then there's a negative 14 here. Positive 5 and negative 14 will give me a negative 9x total. And then this is the only number, negative 14 and positive 32. These are the only two numbers. When I combine them, that gives me an 18. Right? Okay. What are the factors we need here? X. Good job. X. Good job. Because these two numbers, when you multiply them, they're 18. When you add them, they're a negative 9. So this one gives the x equals what? 6. The other one gives the x equals 3. So how many solutions we have? 2. Are we going to accept both? We have to check. What am I going to check? When I plug in 6 to the original question, does it give me a negative ln anywhere? So if x is 6, what's 6 minus 2? 4. ln 4 is okay, right? We only cannot take the ln of the negative number. So it's not giving me a negative number here. That's good. But I still have to check it here. 14 times 4 is, actually, maybe it's going to be easier to check here. 14 times 4 is 56, and 56 minus 32 is definitely a positive number. So this is the 2. And 6 plus 7 is 13. That's not a negative number. So 6 is a very nice number. We're accepting 6 as a solution. It never gave me a negative number. We're going to do the same thing with 3. So we're going to take the 3 and we're going to check if 3 gives us any negative ln. What's 3 minus 2? 1. Is it a negative number? So it's good here, right? Now let's check here. 14 times 3 is 42. 42 minus 32 is 10. Is it a negative number? So it's good here. And 3 plus 7 is it a negative number? No. So this is also a good solution. We also accept it because it never makes us to calculate the ln of a negative number. So both of these will be accepted as answers.
We have one needed number.
So look, ln 5 has an answer, but ln of negative 5 is errored by the calculator. There is no answer. You can find the ln of 10, it does have an answer, but ln of negative 10 doesn't have an answer, so it's undefined. So you cannot take the logarithms of the negative number. So we're checking if when we use these x values, are they giving us any negative number inside after the ln function? That's what we're checking. Yes, Alan.
So one of the answers she was giving x equals 6 and x equals 3, or she had
Sure.
sum and add up together.
Okay, it might be the sum, or it might be listing the solutions. If it says list the solutions, this is what you give them. If it says sum of the solutions, you will add the 6 and 3 and you will give them the 9, right? So this part, I'm gonna let you read the question and you will decide which one. Yes, we can take the ln of a negative number, it's an error, undefined. ln of a negative number or log of any negative number is undefined.
X is equal to -6 and plus.
Okay, good question. -6, I will take the -6 and I will check. -6 minus 2 is -8, that's a problem. So I cannot accept -6 right away at the very first step. But if this wasn't a negative, then I will still check with this guy. If it is not negative, then I will still check with the last guy. I have to make sure that none of these going to have a negative number to accept it as a solution.
So the solution is equal to
Yes. Okay.
this number we have to check in the
On the original problem. Yes. Number 6. Number 6. Solve the exponential equation, which is e to the power of x plus 3 equals to 5, and express the solution in terms of natural logs. Solve e to the power of x plus 3 is equal to 5 and express the solution in terms of natural logs. Okay. When an exponential equation cannot be expressed with a common base, like in this case, e is a special number in math. We talked about this before. It's like a 2.72 value, and this is 5. There is no way I can get them in common base numbers. So what we're going to do is we're going to take the ln of each side. So we're going to take the ln of the first side. So I need ln of e to the power of x plus 3. And then I also need to take the ln of 5. So this is step number 1. We're going to take the ln of each side. Now, why am I doing this? Because taking ln of something means retrieving its power, its denominator. So according to the power rule of logarithms, when I take the ln on the first side, x plus 3 moves to the front, and ln e is just 1, so I can ignore it. So taking the ln on the first side, it only leaves me alone with x plus 3, and ln e disappears because ln e is always equal to a 1. So this portion is going to only get me x plus 3, which is very nice. On the right side, ln 5 is an expression only calculator knows the value. If you're curious how scary that decimal number is, we can ask Desmos what is ln 5 is. We will not need to find its value, but I'm just going to show you ln 5 is only calculated by a calculator. So ln 5 is such a crazy decimal, but we don't have to write it here. We're just going to leave the answer as ln 5. That's what this part means here. Leave the solution in terms of natural logs. That's what it means here. Now, is x alone? The only thing bothers the x is plus 3. So if you subtract 3 on both sides, x will be equal to ln 5 minus 3, and this will be the expected answer for this question. This is what leave your answer with natural logs means. Even though ln 5 is a decimal number, we're not going to find its value. We're just going to leave it as ln 5 minus 3 is the x's value here in this problem. Now, John, I can have your question.
They wanted us to use the calculator for some of our homework questions.
For this homework, 6.3 and 6.5, no.
No, for a different.
Oh, yeah, I said that in the class. You can use calculators for Alex assignments.
Okay,
Yeah.
so I have to purchase it.
No, you can just go to Desmos.com, this website, Desmos.com, calculator. It just does everything for you.
Okay.
Okay. All right, that's number 6 on the test. Yes. LNE part. Okay, let's do it here one more time. Actually, I don't want to erase it, so I'm just going to add an additional page here. So the question was e to the power of x plus 3 is equal to 5, right? Okay. We said because x is in the power, x is in the exponent, and we want to solve for x, we're just going to take the ln of each side, right? So logarithms are perfect, people, because ln means the power here. So when I take the ln of the e to the power of x plus 3, remember the power rule, x plus 3 goes to the front, and then we just get ln e here, right? And then this one is just ln 5. Now, ln e is always one same number, which is 1. This is a rule that we talked about before, and this is always 1. ln e is always equal to 1. And we have the x plus 3 here, and that's equal to the ln 5. So x plus 3 times 1 is just x plus 3. That's equal to ln 5. So in order to solve for x, I just have to subtract 3 from both sides. So ln 5 minus 3 is what I need for the x to be. So the answer I will choose on the test from the answer choices is ln 5 minus 3, what I will pick for this problem on the test. Yes, okay. ln is, so look, when we have log base 5 of 25, right? This means what power do you need to go from 5 to 25? What is 2? So if log, the base is e, the natural number e is a number like 2.72 in math class. It's just a natural number. They call this as natural number. And it's a very important number because in world, many things depends on the natural number. So when log base e, they don't just call it log base e, they just simply call it ln. So ln is a log function where the base is e. Base is not 5, base is not 10, base is not 2, base is e, so we call it simply ln. And ln e is 1 because if ln means the base is e, I need to raise e to the first power to still get an e. Therefore, ln e is equal to a 1. Okay. All right, that was the number 6 from the text. Number 7. Number 7 on the test. Okay, so we're gonna write this log base 5, parentheses, at the top I have a squared, and here I have cube root of x, and I have m as a difference or sum of the logarithms. Sum or difference of logarithms. So this is lesson 4.4. We talked about properties of logarithms in 4.4. So the question is, if we have log base 5, and then the top number is a squared times cube root of x, the bottom number is m, we're going to change this to a sum or difference of logarithms. Okay.
So we use the quotient property.
We use the quotient, we use the product, but let's see which order we're going to apply them. So first, as China said, it looks to me using the quotient rule makes sense, right? Because quotient rule says If two things are getting divided, we can rewrite them by what? Subtraction, right? If two things are getting divided, we can rewrite them as what? Subtraction. So the first part is log base 5, and we have a squared times cube root of x minus, we're going to write the log base 5 again, but the second thing we need is this time m. So because of the division, we are able to rewrite them as subtraction, right? Okay, what else? What's happening to these two things? We are multiplying them. If you are multiplying two things, how are you going to separate them? With a plus, right? So multiplication means we have to separate them with a plus. So let's separate these two. First one is log base 5, and what's the first thing?
A squared.
A squared. So the multiplication will give me a plus. I will rewrite the log base 5 again, and then the second thing is what? Cube root of x. Let's just write it as cube root of x for now, right? And I'm going to copy the last one, log base 5 of n. Okay. We have to do a little trick here. Logarithms, they don't like the radicals. We have to do a magic here, and we have to rewrite the cube root of x. What is an equivalent expression for cube root of x?
1/3.
Good job. This one, I can erase it, cube root of x, and I can just basically write it as x to the power of 1/3, because all radical expressions can be written as a fractional power. Okay. Now, why are we doing this? Finally, we have the power rule to apply, right? What does power rule say?
Put the power to the front.
Yes, we're going to take the power to the front. Therefore, the first one is going to become what? 2 times log base 5 of a. We're done with the first guy. Plus.
5.
So there's a power here that I can move. So this power is going to move to the front as 1/3 times log base 5 of x. Last one doesn't have a power, so I don't have to change anything. I'm just copying the last one. And this will be the answer they expect to give us on the test for this question. And this is how we apply the product of properties of logarithms on a given expression like this. Any questions here for number 7? Product rule, quotient rule, and power rule. Those are the 3 important rules for logarithms, right? Okay. Number 8. Now for number 8, I have 2 matrices. Matrix M is 6, -3, 4, -8. And I have another one, N, and N is 1, 2, -2, 5. Question is, find 2m minus n. So we have 2 different matrices, matrix M and matrix N. They want us to find 2m minus n. It's a very easy question. I hope everybody can answer this one. So what do you think I should be doing first? What does 2m mean? 2 times m. What does it mean? All numbers in m. Oh, this is a different than what we did because there's no x here. So we're not solving for x. This didn't come like x is equal to or x, bless you. This is not like 2m x plus 2m. So we don't have to solve for x here, right? It's a different question than what we practiced at the beginning of the class. This is basically some arithmetic that we're going to do here. We're just going to calculate 2 times m minus n. So what does 2 times m mean? We have multiplied everything by 2 in the matrix M. So 2 times m means 2 times 6 is 12. 2 times -3 is -6. 2 times 4 is 8. 2 times -8 is negative 16. So this gives me the 2m part, right?
Right.
Do you want to handle it as a subtraction, or do you want to change it to a plus and multiply everything by negative here? Which one is easier for you? Okay, subtract. Now we're going to write the matrix n, which is given as 1, 2, negative 2, and 5. To find the answer now, we just have to pay attention to the location for each number. Now, 12 minus 1. What is 12 minus 1?
11.
Good job. That gets me my first number. Next, I will need negative 6 minus 2. What is negative 6 minus 2?
Negative 4.
Negative 6 minus 2. Let's take a look at closer. That's a negative 8. Very good job. Okay. Next, we need 8 minus 2. Good job. Two negatives, they will create a plus. So 8 minus 2 is just a 10. And final, negative 16 minus 5. Negative 21. And this is the expected answer on the test. They will just ask you to pick this answer from the answer choices when you see a question like this on the test. So this is the expected answer for number 8. Any questions? All right. I decided to solve 10 of them only today in class, and I'll take the attendance and I will release you. The other 5 questions, tomorrow, when I have a lunch break, I will just create a YouTube video and share the link with you so I don't have to hold you here more than you need to stay, okay? So question 9. Question 9 on the test is, again, a matrix question. A is negative 6, 8, negative 5, 5. And we have a B, and B is 9, negative 4, 8, negative 9. Now this one says, solve for X, where X plus B is equal to 3A. Okay, this looks like the one that we did at the beginning of the class, right? Because
Yes.
I have an X in this problem, unlike number 8. So, since we did this recently, where do I start?
The equation.
Yes, the equation is X plus B is equal to 3A. And we want to solve this equation for what? X. So, subtract B on both sides. So X will be equal to 3A minus B. Is the X isolated?
Yes.
Yes. This means if I want to solve for X, every number in matrix A will be multiplied by what number? 3. Then I'm going to subtract those numbers from what? B. B will be subtracted from those numbers actually. Okay. So let's set up for X. X is equal to. Now first we need 3 times A. So let's multiply everything by 3. 3 times negative 6 is negative 18. 3 times 8 is 3 times negative 5 is, and 3 times 5 is 15. This part takes care of the 3A portion. Minus, now we're going to subtract B from this, and B is 9, negative 4, 8, negative 9. We're almost done. All right. Negative 18 minus 9. Negative 18 minus 9. Negative 27. 24 minus 4. Good job. 2 negatives, they will change a plus, so it's going to be 24 plus 4, which is 28. Negative 15 minus 8. Negative 23. And 15 minus 9 is 2 not minuses, they always create a plus. 15 plus 9 is 24. This will be the expected answer on the test for X. This is what you need to find on the answer choices, and you will pick this answer for me for number 9. Any questions? We did this, and you're going to practice this again on your Alex assignment. So make sure that you always get it right without anybody's help while you're doing your Alex homework. So number 10, it's another super easy question. It says, find the number x. Find the number x so that the determinant has the given value. So we have this one given. Okay, so this is what the problem says. We have a matrix given here. They're calculating the determinant of the matrix. Determinant is 6. So this is a little bit different than what I showed you at the beginning. The determinant is not unknown. We know the determinant. Determinant is 6. But we just don't know one value of the matrix. So the matrix has 6, -2. The second row has 6 and x. But when they apply the determinant formula, the answer is 6. So it's our job to find the missing value on the matrix. Anybody has any idea? What's the determinant formula? What two numbers need to be multiplied? 6 times x. First, we always start with these two. So 6 times x will be multiplied, and what do I get? 6x. What sign I will always use? Minus. Determinant always uses a minus. Next, we need to multiply 6 by what? -2. And then when they subtracted them, what did they get? A 6. That's what we need to set up and solve. So 6x, 6 minus 2, -2 is -12, but because of the other negative here, it will become a +12 is equal to 6. Subtract 12 on both sides. 6x is -6. Divide each side by 6. So the expected answer here is -1. X must be -1 here if the determinant is equal to 6. This is how we're going to do number 10 on the test. Feel free to ask if you have any questions for number 10.